Hello students, welcome to the 11th lecture in partial differential equations. In this video lecture, we will discuss the type 4 which is based on rule 4 for solving the partial differential equations. So for this, let me consider P1, Q1 and R1 be the functions of x, y and z. Then each fraction in 1, if we take each fraction in this P1, Q1 and R1, so it will be equal to P1 dx plus Q1 dy plus R1 dz divided by P1p plus Q1q plus R1r, right? And this is known by the well-known principle of algebra. Now, if we suppose the numerator is exact differential of the denominator. So what is the assumption in this category? That the numerator, so that is P1 dx plus Q1 dy plus R1 dz. So this is the exact differential of the denominator. So that is, if this is nothing but derivative of the denominator, then 2 can be combined with a suitable fraction in 1 to give the desired result. So that is how you can combine them, and then you can finally tell the required integral in this case. We will look into the example and then you can get more clarity of this concept. Another note is, in some problems another set of multipliers, so we may even require another set of multipliers in other examples. So if we consider the another set of multipliers to be P2, Q2 and R2 are chosen, so that the fraction, this fraction in this case also the numerator is the exact differential of the denominator, and then you can combine 2 and 3 and then you can finally give the required integral. Now let me to consider few examples so that we can understand this concept more clearly. So the first example is solve y plus z times p plus z plus x times q equals to x plus y. So this is the differential equation which is given to me. So first of all, we have to write the Lagrange auxiliary equation as described in the previous video lectures. So the Lagrange auxiliary equation will be dx divided by y plus z is equals to dy divided by z plus x is equals to dz divided by x plus y. So that is the Lagrange auxiliary equation. Now easily you can see that if you just what you should do, you should just subtract this, that is dx minus dy. So if you do so, what it will be equal to, it will be equal to y plus z minus x. So how you can consider this? You can consider them to be, if you choose the multipliers as, so choose the multipliers, Lagrange multipliers. So the multipliers are nothing but 1, minus 1 and 0. So that is the first set of multipliers. So what it will give me? It will give me directly, that is dx minus dy divided by y plus z minus x. So this will get cancelled out. So what is it equal to? It is equal to dx minus dy. Now if you take minus common from the denominator, this will be x minus y, right? Again, apply the same approach again. Now you choose the Lagrange multipliers as 0, 1 and minus 1. That is another set of Lagrange multipliers. And corresponding to this, what you will get? You will get dy minus dz, right? Divided by z plus x minus y. So this x and x will get cancelled out. Again, if you take minus to be common, so this will be dy minus dz minus y minus z, right? Now, finally, if you choose the Lagrange multiplier to be 1, 1 and 1, just observe this thing very carefully. If you take the Lagrange multipliers to be 1, 1, 1, so it will be dx plus dy plus dz. Now add the denominators. So you can clearly see y plus z plus x plus y. So all of them, they are getting up added twice. This will be twice of x plus y plus z, right? Now, if you combine these three, so what I'm trying to tell you is, if you combine this one, right, and this one, so what you will get? What you will get? Just see to this. So this will be equals to, that is, implies dx minus dy upon x minus y, right, is equals to dy minus dz upon minus y minus z, and dx plus dy plus dz divided by twice of x plus y plus z. Now observe one thing very carefully. If I ask you what is the derivative of x minus y, so that is dx minus dy. So you can write it down, derivative of x minus y. This is nothing but the derivative of y minus z. Again, this is nothing but the derivative of x plus y plus z. Now this is something which we have discussed in the beginning. So the numerator contains the derivative of the denominator. Just see to this. Am I right? The numerator contains the derivative of denominator, and same is for this one, and same is for this one, right? So now if you take the first two fractions, you have the derivative in the numerator, right, and the function in the denominator. So I think all of us know how to solve such kind of equations, right? So just integrate them. So that is minus y minus z, and minus will get cancelled out. Now if you integrate this, so function is in the denominator, derivative is in the numerator. So if you just integrate, right, with respect to x, what you will get? So this is nothing but the log of x minus y, and what it will be equal to? Log of y minus z plus some log of c1, where c1 is an arbitrary constant, right? So if you combine the logs now, so what you will get? Log of, so this thing I have used up many times in the previous videos also. I think now you should be comfortable. This is equals to log of c1, and finally log a minus log b, this can be written as log of a by b. So that is a x minus y divided by y minus z. This is equals to log of some c1. And finally what do you get from here? If you cancel out the log, so this implies x minus y divided by y minus z is equals to c1. Mark it as equation number 1. Now if you combine the second and the third one, so what you will get? Again, if you use the second and the third, or the first and the third, any one of them. So if you use the first and the third fraction, let me to use that. Again, you can use any of them. What you will get? You will get d of x minus y divided by x minus y, right? So this was with a negative, I think, right? This was equals to derivative of x plus y plus z divided by x plus y plus z, twice of, right? Bring all the terms on one side, and you can take this 2 here, right, and then you can bring all the terms on the right hand side. So what you will get? You will get derivative of x plus y plus z divided by x plus y plus z plus 2 times derivative of x minus y divided by x minus y is equals to 0. And now if you integrate on both sides, what you will get? So this is nothing but log of x plus y plus z, right, plus 2 times log of x minus y is equal to some log of c2. Apply the properties of log a plus log b is equals to log of ab, right? And then again apply this property, log of m power n. So this is nothing but n log m, right? So that property also is to be used up here. So this will be log of x plus y plus z plus log of x minus y whole square. This is equals to some log of c2. And now finally we apply the properties of log. So this will be x plus y plus z multiplied with x minus y whole square. This is equals to c2. This is equal to c2. And mark this as equation number 2. From equation number 1 and equation number 2, you can finally write down the solution, that is the general solution. So this is phi of x minus y whole square multiplied with x plus y plus z multiplied with comma x minus y divided by y minus z, so bracket close, this is equals to 0, where phi being an arbitrary function. So this is the required general solution for the above partial differential equation. So I hope the method is clear how we will apply the type 4 now. Let me to consider one more example so that we can get more comfort zone in this category of questions. So the second one is y square into x minus y into p plus x square into y minus x times q is equals to z times x square plus y square. Right, now first of all we will write the Lagrange auxiliary equation. So this will be dx divided by y square into x minus y. This will be equal to dy divided by x square into y minus x. This will be equal to dz upon z into x square plus y square. Right, now if you take the first two fractions, clearly if you take the first two fractions, so dx upon, so you should remember all the previous rules. Even you cannot take the risk of forgetting the previous rules. If you take minus to be common, this will be x minus y. Now just cancel out them, right? And what it will be equal to, separate the variables and integrate it. So this will be y square dy plus x square dx is equals to 0. And what is the solution for this equation? All of us know this is nothing but x cube plus y cube equals to c1. Mark this as equation number 1. Now, if you want to choose the another set of Lagrange multipliers, so let me to take the set of multipliers to be 1, minus 1 and 0. So what I will get? I will get dx minus dy whole divided by. So what it will be? They said it will be y square into x minus y minus x square into y minus x. Am I clear till here? So what it will be? Let us, club few terms. So this will be dx minus dy divided by, if you take x minus y to be common, so this will be x square plus y square, right? Now combining the third fraction of 1 with the fraction 3. What I am saying? I am saying that dx minus dy is equals to x minus y divided by x square plus y square. This is equal to what was the third fraction? That is dz divided by z times x square plus y square. So this will get cancelled out. And now you can see this is nothing but derivative of x minus y divided by x minus y, and this is derivative of z divided by z. So function in the denominator and derivative in the numerator, all of us know how to solve. This is nothing but log of x minus y. This is equal to log of z, and this is nothing but log of some c2. Applying the properties of log, what you will finally get, that is x minus y divided by z equals to c2. Mark this as equation number 2. So from 1 and 2, what I can say? I can say that phi of, that is x cube plus y cube, comma x minus y divided by z, so that is equals to 0, is the required general solution for the above partial differential equation. So I hope this category of questions, that is the type 4, which is used for solving the partial differential equations, is clear to you now. In the upcoming video lectures, I will be taking few more problems which are based on this type of questions. So for more such videos, do subscribe to our YouTube channel and do not forget to press the bell icon. Thank you so much.